Check your connection for you. What's in there? Oh, that one. You don't have to talk to me now. That is amazing. You don't have to talk to me. I only want you to see that. I do not do I'm a very important. For every upon a cost, I only want you to see that. That's a cop. You better ask them if they can.
Hello and welcome back once again. Yesterday, we started our lecture on the introduction to Python programming. And I gave some background about what Python programming is meant to do for us, most especially with regards to data analysis. And we said that in almost all settings of our life, we process data in some way. And even in the age where we have a lot of technology to assist in data generation and data processing, tools like Python becomes very much important in our everyday life. So we try to look at some of the basic and very basic functionalities of Python. We may be using it to do some simple computations, like, if you like, we can do 2 plus 2, and it gives us the answer as 4, 2 raised to 4. It gives us the answer 16, and so on and so forth. That is the most primitive thing that you may want to use Python to do. But it is really designed to do sophisticated stuff. We will build our knowledge into the power of Python gradually. So yesterday, we talked about data structures. Data structures, simply what it means is that in life, we have a certain way that we put data together. And that is the idea around which data structures in Python are created. For example, we are likely to put some of our data in the form of a list. Let's say you want to go to the shop and get some items bought. It's always a good idea to plan your, you're going to buy the stuff by putting down a few records on them, basically listing the things that you want to go and buy from which shop and from which shop. Yeah. So that's an idea of a basic data structure. The way you might want to put data together can be more complex than just listing some items. But let's start from there. So yesterday, you remember, we talked about one of the basic data structures in Python called lists. And just even look at the name. It's just the everyday word we use. Oh, give me the list. I want to go and buy these things. So Python also has that data structure to help you compile your list. So for example, I said in our setting as teachers, we might want to create a list of students' scores. So scores is here, and this is how you create it. We did all of these things yesterday. So I want to use the opportunity to kind of review them before we start today's work. So scores, that's the name of the list you are creating. I'll be talking more about how you create names to hold your data. There are a few things you need to be guided by. So scores is the list name, and these are the items. When you are creating a list in Python, you put the items in square brackets. That tells Python that this is a list. So when I do this, type this in a code cell, all I need to do is to run. I can run it by clicking on this play button. See where the cursor is. Or I can do, when you hover your mouse on the play button there, you get some screen tip. It says, run the selected cell and advance, which is having the shortcut, the keyboard shortcut as Shift plus Enter. So sometimes because your hand is already on the keyboard typing, it saves time for you to use the keyboard shortcut than coming to pick the mouse and drag into some other button. So you do Shift plus Enter. It kind of runs the cell and gets you back to the next cell. So I've created a list. If I want to see the content of the list, I can just type in a notebook, Jupyter notebook like this one. I can just call the content of the list by just mentioning the name which I have given to that list I have created. The name is scores. So when I do scores, it brings out the content, which is 10, 12, 20, 15 in square brackets. And I also said that when we have created our lists, just like in everyday life, when we have a list, all the operations we can perform on that list, Python gives you all the methods to be able to do the same thing here. So maybe on a paper list, it will now strike your mind that, oh, I need to insert this item. Oh, I need to remove this one, and so on and so forth. All of them, there are methods to do them here. But before we get to those methods, let me even talk about what we did yesterday in terms of accessing specific elements in the lists. This is more useful when you have a lengthy list, which will be difficult for you to be scrolling for specific items. So you can use Python indexing. You can write that keyword somewhere, indexing, I-N-D-E-X-I-N-G. Indexing is like, when I have this list, Python automatically assigns index numbers to each of the elements. So the first element, 10, the second element, 12, the third element, 20, the fourth element, 15. Each one has an index number, just like you doing this program, each one of you having an index number. Python gives default index numbers to items starting from 0. So Python is usually called zero-based indexing, or Python uses zero-based indexing. So the first element will be given index number 0, and it follows like that. So 0, 1, 2, 3. And you have to be conversant with this way Python does its indexing so that it doesn't confuse you with the way we see things. We would have seen this one to be 1 because humans count from 1. Python counts from 0. Python wants to count things from 0. So what is 1 for you is 0 for Python. What is 2 for you is 1 for Python. What is 3 for you is 2 for Python. You have to get that thing, that logic very simple. So if I want to access a specific element in the list, I use indexing. Indexing also, you specify the index you want to take from the list by using a square bracket. Yesterday, I told you, for now, we have 2 uses of square brackets in Python programming. Very important for you not to forget about these things. So if I want to access a specific element, I know I have to use the index for a list. I have to use the index number of the list. And then I put that index number in a square bracket. So this is what you do. I type the name of the list or the objects. You later understand these things very well. So I just do scores. That's the name I give to the list. And then square brackets 0, which means I want to retrieve the element at 0 index or index number 0. And when I run it, it gives me 10. It says, okay, the number at that position is 10. Good. Python can read also from backward. It can read from backward. To read from backward, you use negative numbers. And that starts from -1. So the last element in this list if you want it in a shortcut way, well, I could have done, this is 0, 1, 2, 3. So when I do scores, open square brackets, 3, that is index number 3, close square brackets, and I run it, it will give me 15, which is the same as the last object. And I'm just trying to make you understand that it will be probably easier if you can count from the bottom of the list, instead of running through 1, 2, 3. If it's a long list, that's going to take some time. So Python gives you that flexibility to start looking at things from behind, and that is using negative indexes. So the last element is -1, this is -2, -3, -4. So when I do scores -1, it will start reading from the bottom of the list or from the end of the list, and it will tell you the number at that position. It tells you 15. If I change this -1 to, let's say, -3, so now let's count. -1, -2, -3 will fall on 12. So if I do scores, square brackets, -3, and run that cell, it has to give me 12. And it gives you 12. These are basic ideas. You need to pick them on your fingertips. They will be very much needed in an advanced data analysis. So now let's come to when we want to modify our lists, when we want to perform some operations on the list. Some of the operations can be that we want to remove some item. Others can be that we want to insert some item, and so on and so forth. So let's think of if we want to insert. Let's begin with insert first. If we want to insert, we simply have to do this code. We type the name of the object. Then we do dot insert. I want you to have your mind on something. Python as a language is structured around dot notation. So most of the things, most of the methods, most of the modifications we'll be doing to objects, we'll be using the dot notation. So you need to pick these things. You are learning a language, just like you'll be learning English. You have to be very conversant with the rules to write well and to speak well. So begin to get things in terms of the language, not because of, don't focus so much on how a particular thing is done, but how the language actually is like. If you get the language part of the whole business, it will make it very easier for you to code simply. Okay, so scores.insert, we want to insert something. We want to insert maybe another number. If you look at the list we created, 10, 12, so maybe let us insert 20, no, maybe 50. So scores.insert, then open square brackets, no, normal brackets, parentheses, and then a closing parenthesis. Let me show you something to do. If you are using Jupyter Lab, as I'm using for the first time, the behavior of your brackets will be like, if you press to open, you will have to manually press to close. But we can change that behavior so that when we open a bracket, the closing one comes automatically. So that one, you come to settings. And then in the menu, you see auto close brackets. So make sure you go to your program and check this one. Then automatically when you open a bracket, it will close automatically so that you don't have that problem of getting your closing and opening parentheses wrong. So scores.insert. This is how the insert function is a function which can be applied on an object. And when a function is applied on an object, that function is normally called a method. That's the only difference. Otherwise, there's no technical difference between a method and a function. So this function insert, because I'm applying it on an object, is now a method. It takes these arguments. You have to specify the index location. You see, list is indexed. All of them have inherent index numbers or implicit index numbers. So if I'm inserting, where do I want it to be? Do I want it to be at the beginning, at the third position, at the end, and so on and so forth? So you specify the index location. So for example, we want to insert it as the first one. So I'll insert 0, then comma. After the comma, I'm now going to type what I want to insert. The first one is the location I want it to go. The second one is what am I going to put there? So let's put 100 there, just for it to be very much conspicuous that, oh, okay, we have put something there. So when I run this, you will see that it's quiet. It's quiet means that it has done what you said it should do. Then you can call the lists, or you can call the object you have created by typing the object name and running the cell to see the new content of the object. So you can see 100 is here at the beginning because I said you should put 100 at index location 0. So that's what it is. So you can insert even, let's say we want to insert at location 0, 1, 2, 3. Let's say location 3. We want to put there the number 10. That tells you that the current number at position 3, 0, 1, 2, 3, which is 20, will now shift to a 4th position, index position. So let's run. Okay, so when you call the list again, you will see that we have the 10 inserted at 3rd position. Okay. There are also other methods to use to insert or to update your list. For example, I may be interested in inserting at the end of the list. If you want to insert, maybe you want to add to the list from the bottom, populate the list from the bottom. That one, there's a handy shortcut. There's a handy method you can use, which is the append method. So the append method, like the name suggests, append is always at the end. We'll always add to the end of the list. So when I do scores.append, open closing parenthesis, then inside it, I want to put what I want to append. Let's say 1000. And of course, inside the same code cell, I can call for the content of the object I have created, which is scores, so that when I run, it will show the content automatically. So now you see that append has added 1000 at the end of the list. So if the business is to add to the end, you can use the append. Of course, you can also use the insert and indicates the last index position, which is the same as append, but append doesn't require you to think about the index position. It just reads that and put it there at the end. Okay, so now what about if we realize that, oh, there are some elements in our lists we don't want them to be there. Maybe we have a change of idea. We want to remove them. We want to remove them. Or maybe we want to even replace them. I'm sure by now you are beginning to get an idea. I want you to follow the language. If you follow the language, you always begin to think of an idea. Okay, if this was done in this way, then based on the way the language works, this new thing is most likely to be done this way. That's the idea I want you to develop. Yeah, so as we move forward. So if I want to, let's say, remove an element from the list, there is a method called remove. You see, Python is not difficult. All of the things I'm typing here is English. So I can do scores dot remove, open, closing parenthesis, then I have to specify what I want to remove. But this is how remove works. See, I have 10 here, I have 10 here. So 10 appears twice. So when I specify 10, it will not remove all the 10s, like 2 10s we have. It will remove the first instance of the 10. That is how the remove method works. So when I do 10, so scores.remove, open parenthesis, closing parenthesis, and inside the parenthesis, if I put the 10 and run that cell, okay, let me call for the content automatically. So scores, so this last bit of the code is just saying that, okay, when you do scores.remove in parenthesis 10, show me the content of the object called scores. That's the meaning of the code. So it tells me the content is now 112, 10. So now see, it removed the first instance of the 10. So we are left with the 10, which comes after the 12. So 100, 12, 10, 20, 15, 1,000. So that's how the remove method works. There's another way. Python always has multiple ways of doing the same thing. That's the kind of flexibility you can get from Python. There's another method which I can use to do that. That is the pop method. What a pop method does is that it removes an element from the list using the index location of the list item. And then it shows on the screen the element that was removed. When we use the remove method, it just removes it. It doesn't show you that, oh, 10 was removed. When I do scores.pop and then specify the index location of the element I want to remove, it will remove that element at that index location and show me that, okay, this is the value that was at that index location and which is removed. So let's try. So let's say scores.pop, and I want to remove the item at the 0 index. If you check our list, you see the item at the 0 index will be 100. So when I run it, it should remove 100. And it shows that, okay, what is removed at that index location is the value 100. Okay, so maybe that is a little more informative than using the remove, but they all can do the same jobs. It's about which one is more appropriate at which time for you. So you have that full flexibility about which way you want to execute your operations. But there's another behavior about a pop which can be helpful. When I do scores.pop, and I do not specify any index location, the pop method will assume an index location for me and goes ahead to execute. And the index location, it assumes if you don't specify the index location, is the last index location, the bottom. So when I do scores.pop, open, closing, there is no specification of an index number, and run it, it is going to remove this 1,000. 1,000 is at the last index location. So, and it will show you the value that was removed. So let's run it, shift, enter, and then you see 1,000. Now I can run, I can call for the scores to see the new content. So you see the 1,000 is gone. So now we are left with 12, 10, 20, 15. Another way we can add to our list, sorry to go back to the adding. I should have added this bit to when we're doing the adding or appending or inserting. Another way you can update the list is to use the plus. This plus symbol is called concatenation. So I can say scores plus something, and it will add it. Normally, this is useful when I am adding a bunch of items to the list. So if I do scores, let me first show you something. If I do scores plus, let me change them here, 100, 200, 300, 400. If I do scores plus these lists, you see they are in square bracket because it's a list of items. It's not just one. If I meant to add just one, there will be no need for the square bracket. It will simply be scores plus, let's say 100. But if they are coming together as one unit, a list, then you pass them in a list notation, which is the square bracket. When I do this, when I run this, it will show me, okay, this is the new content. 12, 10, 20, 15, that's the old one, plus the new list, 100, 200, 300, 400. But when I run scores, you see, when I did this, it will show me. When I run scores, I expect that I see this new updated list, but see what will happen. The old one. This is the default behavior in many of the things you'll be doing in Python, because Python, for some operations like this one, will want to initially give you a view of your operations, but it does not really go to modify the underlying record. So here in this case, if I want the values to be updated with the new list I am adding, this is what I can do. I can set the object name, scores. What I have to do is that this is the new content, scores plus the list. Then I have to store it again using the same object name. So this is what you will do. Scores is equal to scores plus the new list. What this means is that, okay, store in the same object name, which is scores, these values. What is already in scores plus this new addition? When I do that and run scores, now the scores is effectively updated. Any questions so far? You can unmute your microphone if you want to speak. Any questions so far?
Hello, Doc. Please, I don't have a question, but I want to suggest, if it's possible, some of us have just downloaded the app.
Okay.
Can you go back and show us how to use it?
Okay, so let's manage it this way. The session we are having right now is being recorded. The one we did yesterday was recorded. So first of all, you will have to go back to those videos. When we finish today's session, I will quickly upload it and send you the link. You have to watch these two videos. They are supposed to help you more than 50% get to the same page as we are. And then you put down every challenge you have. When we meet for the next session, I'll address all of them before we move ahead. Is that okay? Hello, are you okay? Okay. So these are a few operations we can perform on a list object. There are other methods you can use to perform modifications on your list. Examples include del, D-E-L. So scores.del. Go put it down. You have to go and read on how del method works on lists. You also have to read on clear. These are methods you can apply on lists. Clear. So in this case, scores.clear. Go and read on how that method works and practice. Just play around it, create some lists, apply all of these methods on them to see how they work. So that is about lists. Still, I want to ask any questions before we move to another data structure. Okay, so this is a beautiful idea, but it is too basic, such that many of the operations we do in real life this way of, storing data may not support it. For example, if we even want to extend the idea of storing student scores in a list, what if we have, let's say, multiple assignments or multiple quizzes that we have done on the students? Okay, that will mean that we have to create several lists. For example, let's say quiz 1. So quiz 1. And before I do this, let me take the opportunity to address some of the guidelines you have to follow in creating object names. Quiz 1 is an object name. In Python, your object name can never begin with a number. it can begin with any letter, but not a number. It can begin with a letter and then the rest can be numbers. The only restriction is that it doesn't need to begin with a number. If the way you want to name your object should be like a number, then what you can do is that you can precede, for example, I can do this, say 4 is an object name is equal to, let's say, this string. I'll explain what I'm doing later. You see, Python will give you an error message which says syntax error. And then this is how it is explaining the syntax error. Cannot assign to literal here. Maybe you meant double equal to. We'll later understand what double equal to means. But all it is trying to speak to you is that this is wrong. This is against the rules. But I can do the reverse. I can do 4 equals 4. That's okay. If I just desire that my object name begins like a number, then Python allows this. I can precede a number with an underscore like this, and then say 4. This is acceptable. This removes the number of the object from it. So this is not a number. This is acceptable as an object name. Yes. Another thing you need to note when you are creating object names in Python is that your object name should not, you shouldn't use Python's reserved words or keywords as your object names. The main reason why you shouldn't do that is because Python uses those words. If you also use them, it can create confusion when you are doing your coding. For example, if let's say that word is a column heading of your table, and you are applying some operations using that column heading, and that same word is a Python's reserved word, Python uses it. When you call that name, Python gets confused whether you are calling a function or it is your table column. So that's the main reason why you shouldn't use Python reserved words. You can read on the list of Python reserved words. When you go to Google, you can search for Python's reserved or Python's keywords. So basically that's it. Apart from that, your object's name can be anything. And another thing you need to also notice that your object's name should be descriptive of what you are doing. For example, if I am creating, there's a list for students' course, for it to be descriptive of what I'm doing, I can't just use any object's name which someone needs to ask me before he knows what I'm doing. It should be, to a very large extent, self-explanatory, self-descriptive. So quiz _1. I could have just done quiz 1. But you know, in normal writing, if you were to type this in Word, you would have done quiz space 1. In programming, the idea of spaces is so much problematic. So what we use to represent spaces can be underscore. And that is how Python programmers usually do. So quiz underscore one is quiz is like Squarespace one, but all of them is one word. This is the best way to name your variables or your objects. Other people also, so this kind of casing, quiz underscore one, is what is described as snake case or snake casing. So I can do quiz underscore one underscore, let's say scores. Okay, this is making it even more descriptive. So apart from just saying quiz one, I'm also adding scores for everybody to know, okay, this is scores. But see the way I've done it. If you want to really gauge this, you'll see it to be like a snake. So it curves in here, it moves out there, it curves in here. So that's why we call it snake case. So I can use this idea to give a descriptive object names. So I'm going to create a list of these grades or scores. So someone gets 10, someone gets 12, someone gets 12 again, someone gets 13, someone gets 18, someone gets 9, someone gets 19. Which means that if I did quiz 2, quiz 3, quiz 4, I need to create lists objects for all of these kind of scores. So this is quiz 1. I can do quiz 2. Okay, so I have quiz 1 and quiz 2. Now I can run to create these two objects. So they are created and it's in the memory of your computer. If I want to get the content of each one of them, I can call the name. So for example, I can say quiz 1 scores, run it, and it will show me, okay, this is quiz 1 scores. I can equally do the same for quiz 2. But just imagine if you create 4 or 5 quizzes, and each one, you can keep it in a list like this, but there are some other data structures that will be a lot more helpful than lists because of the nature of what we want to do now. The main reason why lists may not be preferred, some other data structure will do better. I'll talk about that data structure very soon. Is that just imagine one of the clear challenges with using lists to do this kind of exercise. If we have to send, let's say, the scores, because each of them is a separate list, we will have to send them as separate, not as one packet. But we can use another data structure, which will put all of the lists together as one object. So now, as you can see, we have quiz 1 score as an object, quiz 2 score as a separate object. If there is quiz 3, that will be a separate object, as many separate objects as the number of quizzes that will be created. And that can be plenty. There is another data structure called dictionary. Dictionary. It is spelled the same dictionary, you know, which can combine all of these number of lists as one object. so that we can apply methods on that object in a more efficient way. Dictionary. So let's look at how the dictionary object looks like. So if I want to create a dictionary to house all of the quizzes I'll be doing, I'll give the dictionary an object name. So let's say students scores. This is how I prefer to call the object. So you can give it a more descriptive name. Then for a dictionary, you use curly braces. You have to understand what we are learning is a language. Languages have rules. For a list, you use square brackets. So you cannot say you are creating a list and you go and use a different thing. For a list, square bracket. For a dictionary, you use curly braces. This is how they look like. Okay. And how does a dictionary look like? If you get a normal dictionary, which has words and their meaning, the basic structure of such a dictionary is a word and meaning pair. A keyword and its meaning pair. So it's a pair of the word and its meaning. That's the same idea on which the Python dictionary is built. So Python dictionary is a key and value pair, a key and value pair data structure. So in this particular list where we have quiz 1 scores, quiz 2 scores, there can even be quiz 3 scores, quiz 4 scores, and so on and so forth. The quiz 1 score, this one, becomes the key. And then these elements in this list becomes the values. So this can be one key value pair. This, another key value pair. The value can be a list. It can also be a single value. If it is a list, you just remember to put it in a list notation, which is square brackets. So what I'm going to do is to say, and then your values are labeled, so they have to be typed as strings. In programming, a string is any character which is not a number. I mean, let me give that basic definition for now. There can be some other technical meanings, but basically that's what it means. Any character which is not a number. This 10 is a number, so the computer knows numbers. The computer doesn't really know strings or characters apart from numbers. So we need to guide the computer not to see everything we are typing as a number. Otherwise, when it is not able to read it as number, because it will put on numbers lens. It wants to read everything from a numbers perspective. If it doesn't see it as a number, it will throw error at you. But when you tell the computer, okay, this thing I am typing is not a number, so don't read it as a number, then it will read it correctly. One of the ways to do that is to use quotation. In Python, you can use double quotation or single quotation. Single quotation is easier, so I always use single quotations. So I'm going to do quiz 1 score. So that is my key. And I put it in quotation because it is not a number. Then I bring colon. So the colon separates the keyword that you want to find from the dictionary and its meaning. In this case, the values. The colon separates the key from the value. So I'm done with the key, quiz 1 score. Colon is the join between them. Then because this one is a list, I bring my list notation and then do 10, 12, 12, 13, 18, 19. So I am done with one key value pair. Then when I'm done with that, I have to come to the end of that first key value pair. The end of it is after the closing square brackets. I do comma. So this comma separates the various key value pairs in the dictionary objects. One best way I can do that is that I can press enter to drop this thing down. I will demonstrate another one. So let's continue. So comma, then I'm coming to begin another key value pair, which is my key, which is going to be a string, is the label, is quiz underscore 2 underscore scores. That's the key, quiz 2 scores, colon. Then the values are lists, so I bring a list notation, and it is a list of the numbers 10, 9, 20, 12, 15, 17, 20. So let's say this is the 2 key value pairs. So that's how you create a dictionary. The key difference is that the dictionary is just one object, which is going to encapsulate all of these things. If you are to use list to do that, you have to create multiple objects. So for the dictionary, we can send the whole of the data, which would have been several separate data in list form, as one data object. So when I run this, the dictionary object is created. I can call for the contents. The name of the object is students underscore scores. Run it, and then it tells you the content of it. Quiz 1 score is this list. Quiz 2 score is this list. And we can do operations. When you have something like this, just like we did on the list, we may want to do operations on this as well. And you will see that this one can even give us some more advanced methods for operating on this dictionary objects. Before I move forward to the operations on the dictionary objects, any questions or just anything? Okay, so now let's see some of the things we can do on dictionary. First of all, we might want to see assuming we have a very big dictionary, a dictionary of many key value pairs, items. What we may want to probably first of all do is to understand the structure of the dictionary. And we can do that by First of all, wanting to know all the keys in the dictionary. So we can do that by typing the name of the dictionary. In this case, students scores. And then doing dot values. Doing dot values will show us, so this is the values method when applied on the dictionary objects, will show you all the values in the dictionary. So you see that it gives you dict values, that's short form for dictionary values. Then you have the values in lists. So you have the first list, 10, 12, 13, 18, 19. And that's the end of it. So you see another comma. Then the second list. I can equally do student scores dot keys to solicit for all the keys in the dictionary. Okay. Then if I want to see all of them at the same time, well, you can just call for the whole object name. You will see the key value combinations. Another way you can get the same information is to type the code, the object name, which is student scores dot items. And it gives you the label or the key, comma, its corresponding lists. Then another key and its corresponding list or corresponding values. Okay. We may want to know okay, let me put it this way. Unlike lists, which is index-based, because of the structure of a dictionary, it will be difficult to use indexing, apply indexing on dictionaries, because it already has a way that we can use to find the values we may want to look for. It has a key which corresponds to values. So we can use the keys to find the corresponding values. For example, if I type the object's name, student scores, and then I index, so this square bracket is for indexing. So when I type here, the key name, one of the key names is quiz _1 _ scores. And I run this. Okay. So let's read the error here. And one of the things you should be very interested in doing is that if you get an error message, you need to go back and read fully what the error is speaking. You will just realize that you will learn a great deal by paying attention to the error messages. Sometimes the errors are just some simple mistakes. For example, if you look at this code, which is giving us errors, we have passed quiz 1 scores as the index on the dictionary so that we find the values corresponding to this key. What I typed here, quiz 1 score, is saying key error. That means what I typed there is probably wrong. Let's go and see why. In the original data, the dictionary, we have the label as quiz 1 score. It is not S. If we want it to be scores, then we can come and update this one and run it. Then the subsequent code will be right. Or we need to type it exactly as it is here because it's referencing this thing. So it is quiz 1 score, not scores. So that tells us that in programming, we need to be highly meticulous because programming is not really for lazy minds. You need to be very thoughtful in everything you are doing. That's one character you need to develop. Okay, so now if you run it, it goes to the dictionary and reads the key, which is quiz 1 score, and retrieves its values. So that's one way you can index, you can find the values that corresponds to a key because the keys are unique. That's why we don't need the idea of an index number in a dictionary data structure. Okay. So we can do equally the same to quiz 2 to retrieve the numbers. Now let's see what we can do. Let's say we want to do a summation of quiz 1 and quiz 2. This is an operation which is possibly not applicable to lists. When we did the list, we had quiz 1, quiz 2. If I have to create quiz 1 and quiz 1 plus quiz 2, I will have to create another object called maybe quiz 1 plus 2, and then do the calculations, which will be too difficult. In dictionary, because the data is stored as one unit, it's easier to do that operation. So when I do student scores, then do this index notation. So this, in this case, this square bracket is not a list. You have to always understand how to use square brackets for indexing or for subsetting, taking a portion or something like that. See how square bracket is used for that, different from how it is used to create a list. So if I want to create another key value pair, which should be a calculation on existing key value pairs, like in this case, I want to create another item called, let's say, sub total, which is the idea of summing the two quizzes. This is a label, so I have to put it in quotation. You have to remember that as a beginner, it's likely you will forget about these things and you get errors, you come back and correct them. Over time, your errors will reduce. So student course subtotal. So when I index this subtotal on the student's course, because it is not currently existing, Python will read it like it has to create it. So I'm going to create it as a calculation of the two existing items, quiz 1 score plus quiz 2 score. So what I'm going to do is that I'm going to say is equal to student scores quiz 1 score The mistake I made was that, not really a mistake, but let's be very clear. See, I was not consistent between quiz 1 score and here. This one was score, no S, and this one was with S. That was just a mistake. So let me remove this one so that it becomes the same. And let me run this one again. Okay. So it's going to be quiz 1 score plus students score index quiz underscore 2 score. Just pay a little bit of attention to this code. All we are trying to do is that we want to create another key value pair on this dictionary item. And we are creating it as an existing key value pair with the label quiz 1 score plus an existing key value pair with the label quiz 2 score. And let's run and see. If nothing happens, it means the code has gone right. Otherwise, we read the error message to see where we went wrong and then we correct it. So now we can look at the new dictionary because we have modified it. So when you look at it, you will see that we now have 3 items: quiz 1 score, quiz 2 score, and then subtotal. And see the subtotal. The subtotal is not like we wanted it to be. We wanted it to add 10 to this 10, 12 to this 9, 12 to this 12, 13 to this 15, 18 to this 17, and 19 to this 20. But this is how it did it. It took this whole list and just appended the second list to it. So you see 10, 12, 12, 13, 18, 19, that is here, up to here. And then it just added 10, 9, 20, 12, 13, 17, 20 to it. Basically, that is how dictionaries understand summation. And that is how lists also understand summations. For example, if I go back to this initial list and I wanted to do, let's say, quiz 1 plus two. And I did it like quiz underscore 1 underscore scores. This one has scores to it. You have to be attentive to that. Plus quiz underscore 2 underscore scores. So quiz 1 plus 2. I'm just being careful if my usage of this plus will be allowed. Equals quiz 1 score, quiz 1 scores plus quiz 2 scores. Let's run and see. Okay, so this plus is the problem. So let me try to modify. So let me do it quiz 1 let me give this label quiz 1 plus quiz 2. That should be fine. Okay. So when I do it like this and I call for quiz 1 plus quiz 2, this is the result. It's going to do the same thing we saw in the dictionary. It's going to take this and append this to it. That is how lists, and of course, what we pass as the values for the dictionary were also lists. So that's how basically it will do. So, which means that sometimes these basic data structures may fail in doing some operations as we want them to do. And that will require us to get some advanced data structures. It doesn't mean that these ones are not good. In fact, these are the basics for all advanced data structures. So now we have looked at lists data structures. We have looked at dictionary data structures. Any questions on them so far? Hello? Are you there? Hello, guys, are you there? If you are there, just respond. Let me know you are there, please.
Yeah, we're there. Yes, sir.
Okay. So now let's look at some advanced data structures. For the records that we want to keep, at least about our student scores, we know that, well, if we take away the need for the operation of summing the two scores, then maybe lists up to a dictionary data structure can be okay, but we will definitely want to do computations like adding quiz 1 to quiz 2, or subtracting or adding some scaling factor and so on and so forth. Okay, so now let's look at some other data structures which will help us to do that. We'll first talk about NumPy. NumPy stands for numerical Python. So basically that NumPy is a package. It's a big package which contains a lot of functions specifically built for doing mathematical and scientific calculations. It's very, very important because of the way it is made to behave. It is almost used in every operation, scientific computations, in medicine, in space calculations, in business analysis, everywhere. So let's see how NumPy works briefly.
It's up to 15 series. I'm not sure was it 2 series. Would you answer the carton? You know, the card just here can tire because 100.
Okay, so for these advanced data structures, they will not automatically be loaded when you open your Jupyter Lab or Jupyter Notebook. All the packages you need to create the basic data structures, when you open your Jupyter Notebook or Jupyter Lab, they are automatically loaded, like operations, creating a list. Once you open the notebook like I have, you create it. Dictionary, strings, even numbers. But for advanced data structures, they will not automatically, be present for you to use. For example, one of them is NumPy. So when I say, when I want to apply NumPy, it will not automatically be there as if I want to do a list or dictionary. If you want them to come for you to use them, you need to import them. You need to import them. Sometimes they are a bit heavier packages. So if you don't really need them, they don't need to automatically load. That will just, waste your computer resources. So when you need them, you import them. The importation of them is very simple. This is how you import any package. You use the keyword import. Then the package name, in this case, is NumPy. So NumPy. It has just become a convention that we want to type with some speed. So packages that come with some lengthy names or longer names, we will want to import them with an alias. The alias should be maybe a short form of it, so that henceforth we use the alias as a proxy to the main package. This is what I mean. So instead of leaving the importation like this, import NumPy, when I leave it like this, it means that anytime I want to use NumPy, I have to type numpy.this, numpy.that. And maybe typing NumPy is too lengthy for me. So I'll do import NumPy as NP. The NP has become like a convention in the programming community, Python programming community. You can import it with any alias of your choice, but if you want to stick with a convention, that's what almost everybody is doing, then you may want to import it as NP. So import NumPy as NP. The importation is done, which means now the functions, the whole of the NumPy package is ready for you to use. And remember that you imported that package as NP. So anything you want to do with NumPy, you have to use the shortcut NP. So I can create the same things we have created, the list of student scores using NumPy. And now let's see how NumPy sees things in terms of doing calculations. So let me say, quiz one scores NP. I'm adding this NP because I want it to be different from these ones I created here. We will compare them to understand certain things. If I don't change it, if I don't change the name and use the same names here, they will come and overwrite these things because they are the same. So that's why I'm adding NP. The NP simply means maybe NumPy. So quiz one scores NumPy is this list. So let me go and copy the list here. No, we can't copy. That will be just a list. So that's how the list did it. So in NumPy, I'll have to generate those scores. So I can do NP dot array. Array is simply a list of numbers or items arranged in some order, either horizontal order like this or some vertical order, or a combination of the two. That's what we call array. That's what we call arrays. So you realize that most of the data we keep in real life, especially in business, is in the array form. Just look at an Excel data. It's array of columns, series of numbers and rows. That's what an array simply means. That's what an array is. So when I want to create an array, which is like the one we did in the lists, this is also an array of numbers. In NumPy, there's a function called array for you to create that. So np.array, then that one I can pass the list inside it. It will convert this list into array. And the array will be just a list of numbers, but it will give it special properties, different from the properties that list gives to these numbers. So quiz 2. Quiz 2 scores NP. Let's do it. NP dot array. Open and closing parentheses. And let me just go and copy the list of quiz 2. Yeah. So we have created two objects, two NumPy objects, like the two list objects we created previously. But because we are using NumPy, remember, we want to go above the limitations of the list and the dictionary. And you saw the limitation when we wanted to perform the sum of the two quizzes to give us a subtotal. See the way it did it. This is not the way it has to do it. But this is how dictionary and list work. Yes. So now let me create this NumPy object. Quiz 1 scores NP, quiz 2 scores NP. And now let me do subtotal. Subtotal NP as this plus this. And let's see the results. Okay, the results is stored as subtotal NP. So let me call subtotal NP so that we can see the contents. Okay, so subtotal NP is now 20, 21, 32, 25, 33, 26, 39. How did it come by this? This is how it did it. This one plus this one. Quiz 1 plus quiz 2, 10 plus 10, which is the 20, 12 plus 9, which is the 21, 12 plus 20, which is 32, 13 plus 12, which is 25, 18 plus 15, which is 33, 9 plus 17, which is 26, 19 plus 20, which is 39. So that is one power that NumPy arrays have over Python list and dictionary. There are lots of power, quantitative power, that NumPy presents. For example, when we go back to the list, so I think I had, so let's do this. Let me go and modify this one a little bit, okay? It doesn't matter. So quiz 1 scores, let me add this underscore ls for lists, so that we see the clear differences. Quiz 2 score underscore ls. And then quiz 1 plus quiz 2, sorry, underscore ls. I just modified the name so that I'm adding the objects to it. When I want to do, let's say, do some simple statistical computations on these lists, so let me call this one here. Oh no, this is, I mean the lists. Okay, so this is lists of numbers. When I want to do statistical computations, so maybe I want to do quiz 1 scores ls dot, let's say I want to find the mean. Now let me run it. Okay, see, it says this object has no attribute mean. So these are some of the deficiencies in some of the basic data structures. it will be very difficult for me to do this, statistics. Let's try to do the same thing I did on the NumPy list. So that will be is one score NP. These are the values. And if I do quiz one scores NP dot mean, let's see if it works. Okay, what do you see? Is able to go through this list, add all of them together. That's the algorithm for the mean. Add all of the numbers together, 10 plus 12 plus 12 plus 13 plus 18 plus 9 plus 19, divided by the count, 1, 2, 3, 4, 5, 6, 7. And this is the mean, 13 points. So this is the mean score. And I can equally do the median score. Okay, so it says NumPy doesn't have median. I'll see how we go about it. Let me check on, I think, node what might be there. So, so there are, what I want to prove here is that there are some basic statistical computations because of the properties NumPy give to the arrays we'll be generating. You can easily do those computations and they are not present using lists or dictionaries. Okay. From time to time, I might be going back and forth between the data structures because that's how it has to be. So at the moment, this is a very good introduction to NumPy. And the point we want to stress is some advantages it provides over using lists and dictionary. But the main data structure, which is designed for advanced data analysis in Python, is called Pandas. Pandas is a word that comes from the combination of panel and data. So that's the idea of the name Pandas. So it's not really an animal name. Okay. So how does Pandas work? Pandas try to put everything we are trying to do from list, dictionary, NumPy into a data structure, which is like what we see in Excel. But Pandas gives us two key data structures, series and data frame. In fact, the two are almost the same, except that the series is like just one column data. And then the data frame is like many columns data, typically Excel-like data. Okay. So if we want to create a Pandas series, all we need to do is to use call Pandas. And like I told you, Pandas is an advanced data structure. It will not automatically load when you open your notebook. If you need it to work for you, you need to import it. So we are going to import Pandas, and you have to check the spelling correctly. And it has become the tradition of importing Pandas as PD, even though you can import it with just any alias of your choice. So import Pandas as PD. Okay, so the only error here is that I didn't bring the keyword as. So import pandas as PD. Okay, that's what it is. Now that pandas is imported, it means all the functions inside the pandas package is ready for you to use. You just need to know how to use them. And it does all the magic for you. Okay, so the dictionary that I created here, let's look at the dictionary structure. A key and values, a key and values is much of the same structure as a table, which has column heading and then the labels under the column. Column heading and then the labels under the column. So a list will create it like this, but we could have created a Pandas series to hold this data. Why do we have to use Pandas series if lists can do the same thing? The key reason is that the list has a lot of limitations in terms of the operations we can perform on this. For example, when we wanted to find the mean of the scores, it doesn't have that method. So we created NumPy data objects, and it's able to give us that. In fact, NumPy is specially designed for mathematical computations. We will delve more into NumPy in later sessions. So you want to use series to do that column of scores, because the series will come with enhanced methods for you to do the computations that you want to do. So it can be done this way. Instead of using list to create it, or even NumPy to create it, I could have used Pandas to create it live. And one beautiful thing about Pandas is that it is a combination. In fact, it is built strongly on NumPy. So all the beautiful things that we want from NumPy, the Pandas data structures automatically inherit them, plus they come in with more flexibilities that are not even present in NumPy. It inherits all the computational flexibilities and computational power of NumPy. I'm talking about the Pandas. It inherits all the computational power from NumPy. Plus, it adds a lot of features which makes it easier for us to deal with it as a data object. So it's very, very powerful. It's very important. So if I wanted to create the first quiz scores as series, I would have just said PD. Remember, I'm using PD because I imported Pandas as PD. So PD.series. And then programming is very case sensitive. The series begins with capital S, not small s. Small s will be seen as a different thing. So PD.series, open and closing parentheses. Then I can just pass the list elements. They are here. Okay. So let me store it as an object name. So let's call it quiz 1 course series. So let me make it S for series is equal to this. And I can automatically call for that object as part of the code. Okay. So when I run this, it creates this data for me. You can automatically see some difference. When we did this one in the list, and you call for it, it will show in horizontal. This one is showing in vertical. This is usually the data, the form of the data we keep when we are using Excel or in business, in a column. So a series is simply a one column Excel data. So it gives you these labels, 0, 1, 2, 3, 4, 5. I guess all of you have used Excel before. Have you? Who has not used Excel before? Okay, that means all of you have used it before. If you open Excel, you will see that Excel automatically has row labels. Okay, someone says he has not used Excel before. Now you can unmute your microphones and join the conversation. It's expected that all of you have used Excel and you have some good knowledge in Excel. Is that true? Do you all have some good knowledge in Excel?
Yes, sir.
I've used some before.
You have used some before, but you are not using it anymore.
Yes, sir.
Hey, why?
But I still have the
you have
app
to
on
use
my
it every day. Okay, so when you open Excel, let me try to see. My computer is a bit loaded, but let me see if I can help. Okay, so this is how Excel looks like. When you open Excel, you automatically see these row numbers. Row numbers from 1, 2, 3, up to very large numbers. That's a lot of rows. And column labels, A, B, C, D, and so on and so forth. Yeah, that is the structure of Excel. The data structures we are approaching to now is very similar to Excel, only that it has a lot of power, some power that Excel may not have. It doesn't mean it's automatically or completely replaces Excel. There are some things that are very much flexible to do in Excel, and you might not have to call for Python. There are definitely other things that Excel will struggle, and it's Python's job. So you have to know the two. Yeah. So I just wanted to show you the structure of Excel, because the data structures we are now learning, series and data frames, you can understand them from your knowledge of Excel. So row numbers, 1, 2, 3, and column labels. Okay, so if you see the series data structure, you will see that in addition to the list that we passed to the series function, you see that there is also another set of numbers from 0 to 5. This is not really part of the numbers we submitted to the pd.series function. It is only there because the rows of numbers needs to have labels. So these are implicit row labels, just like in Excel, you have 1, 2, 3. And just remember that Python is zero-based. So it starts the row numbers from 0 instead of from 1 in Excel. That's the only difference. So this is one column data. This 0 to 5 is the row labels. Okay. So when we have a series, what makes it series unique from lists? We can do most of the computations that is not supported by lists. For example, I can do sum. If I go back to the lists here, so let me insert a row, a cell below, and try to do quiz 1 scores. Quiz 1 scores LS. Just trying to do this one. Dot sum. What this method will try to do is to find the sum of the numbers. It will not be possible. Many operations like this may not be possible on a list, even on a dictionary. But if we have the series data structure, we did that for NumPy. NumPy, I can do sum. I can do quiz 1 scores NP dot sum. It will work. It is 93. On a list, you can't get it. On series like this one, we are moving gradually to the data structure we'll be using all the time. And we have to transition through all of these levels. And everyone is very important. You have to coordinate all of them. On a series, I can call, this is the name of the objects. Quiz 1 scores S dot sum. Is there. I can do the same thing, dot mean is there. I can do the same thing, dot median. It is there. So you see at least some enhanced computational power with the Pandas series. Another beautiful thing that comes with this data structure is that I can, if I want to see maybe the pattern of the scores, I can easily draw a chart on it because it inherits chart methods or plotting methods. So when I do quiz 1 score S dot plots, it will give me the shape of the scores. Okay, it begins with some low mark, but it's generally upward moving. It means the numbers are increasing. The list object does not have inherent plotting methods, and the dictionary too. There are a lot of other things you can do with Pandas series. So put it down somewhere, simply as explore more on Pandas series. Information about these things are just overflowing on the web. You don't need to pay any money for anything. So use YouTube most of the time instead of normal Google. So go to YouTube, Google, maybe Pandas series. Just like that, you get a lot of videos, step by step, very basic to advanced. Pandas data frame, Python lists, Python dictionary. Python this, Python that. Put it there. You have to go and do same search in YouTube on all the things that we have done so far. Any questions, please? Any questions? Please, you can put your microphones on. I wanted to know if you have any questions so far about what we have discussed.
Yeah, sir.
Yes, sir.
So please, I want to ask that on the exams day, are we going to use our computers in performing activities like this?
Yes.
Hey! Yeah.
Yes.
Okay.
You will use computers to sit them.
To sit for the exams.
Hello.
Yes, sir.
I didn't hear the last thing you said.
I'm saying that, are we going to use our computers or laptop to sit for the exams?
Yes, please.
Hello, sir.
Yes, sir. Please go ahead.
Is it going to be our own computers or the?
Yes, it's going to be your own computer because you're using your own computer to learn now.
Then Apple will appear. Or
I mean, why would you think of Apple?
so maybe if you are using our own computer, you can make search. Can make research on what you've already taught us.
Oh, no.
Or it will be a different.
Of course, the questions that will be given to you are very practical problems, which if you refer on the web about how a certain method works, that is really not the point, because in real life, that's how you will do. But when you do that search, either on your own computer or anywhere else, you're supposed to know how what you have gotten is applied to solving that practical problem before you. Are you okay? The person who asked the question, are you okay?
Yes, sir.
Okay, so think of it this way. You are not going to get questions like, what is NumPy? Hello? You are not going to be giving questions like, what is NumPy? So that you can go to the web and type, what is NumPy? And then you copy the answer there for me. That is not really necessary. If you know what NumPy is, we want you to use how you know NumPy to execute a practical problem. Such a problem, you might not get a problem on the web with its solution. So even if you can go to the web, if you don't know how the things you are searching for are applied to solve practical problems, you're going to the web will become useless. So I don't have any problem if you have to go to the web to find something. You have to solve the questions. The questions will be practical. Your computers can assist you to do the coding, and then you write the output as the question will be demanding on a paper. So that will be the nature of the exam.
Hello, sir.
Yes, sir.
Can you give us a sample how the question will be asked?
I'll definitely give you samples. We'll solve a lot of sample questions. Right now, we are just building the blocks.
Thank you, sir.
So we'll solve a lot of sample questions. They are not difficult. Don't panic. Don't think of them as...
We are getting panic.
No, you don't have to. You don't have to.
But we know that since you are there, you help us.
Exactly. That's why we are meeting. So I expect you to do your part of it. Right now, between yesterday and today, we've been able to do a few things about NumPy. Sorry, a few things about Python. Don't go and sleep on it. Otherwise, it will be a problem. Go and read. That's your job as the student. Go and read on them. And I've given you the best way to read. Just go to YouTube. In addition to the videos I'll upload on my YouTube channel, there are a lot of other videos from several other people. Some can even teach it better. explain certain things better. You only do yourself a big harm if you don't want to read and read from the right source. So use YouTube a lot. Go to YouTube, search for Python list. You'll get a lot of videos teaching you Python list, operations on Python list. If I give you a question which is to create a list and perform some operations on the list, you don't have a problem at all. Search on Python dictionary. If I give you operations which require you to create a Python dictionary, because you have known how to do it, and it's so easy if you keep, practicing it, it becomes so easy. You will just create it in your mind. The moment you see the question, okay, you know the structure, blah, blah, blah. Everything is difficult before it becomes easy. And what makes it easier is a matter of practice and experience. So do that part of the job, which is your job. I will definitely do my part, and you can easily score A. But if you don't do anything and you still carry the same old mentality of this one day, I can't do it. Of course, it will happen like that for you. And when you fail, you will write it again. And I pray nobody fails, because everybody will do his work. Okay, so this is where I want us to end today's lecture. It shouldn't be too plenty so that you can go through the video quickly, and it shouldn't end with the video. As you are doing that, cross-check with other videos on YouTube and learn meaningfully. Don't chew it. Learn to understand it, please. So within the week, I will post some assignments around these things so that it gives you the means to play around them. And I will take them for marking. Please, the fact that I'll take them for marking does not say that just go and get someone who is serious about it, copy his work and submit it for me. When you do it, you are paving the way for your failure. Learn it on your own. Deal with your own mistakes. Things that you need to refer, you can always post it in the group. I'll respond to them, or you can personally call me.
Okay, hello, sir.
Yes, sir.
Sir, please, you've not given us the course outline for the program. Okay,
I'll put all of them plus the previous lectures we had, the slides. I'll put all of them in the WhatsApp group today.
Okay. And sir, another one. Can we be accessing you outside your normal time you have?
Exactly. You can always call me.
Okay.
And when you call me and it's like I'm not able to pick, don't interpret it as maybe your call is disturbing. It is not. So call as many times as you have to call.
Okay.
Yeah.
To even arrange for class like this.
Yeah, you can always call for us to negotiate. When you call, it starts from the calling, then we will definitely have some agreements.
Okay.
Yeah.
Okay, thank you.
So I guess we are okay for today.
Yes, sir.
Yes, sir.
Can we get your contact?
Oh, my contact 024 651 2655. So please, one thing I will encourage you to do is when you are practicing these things, try to bring your job into the equation. As a teacher, you will deal with a lot of things that require data processing, at least around student scores. So even if you are watching a video which is using a different setting, import the idea into your work. Okay, so around my work, how am I able to create something around? That's how you appreciate the program. Don't think of it as this is one of the exams I have to go and write without meaning. attach so much meaning to this thing. It's so meaningful. It's going to help you solve all the data analysis problems at your job place. That is how you have to see it. If you do it like that, you will definitely understand it, and it will be very easier. Thank you very much.
Thank you, sir. Computer for no mumba na mumba chen ya de ibio.